All right, hey chemistry. So in this video, I'm going to walk us through how we can actually balance a chemical equation and what that means. So to start, remember conservation of mass or conservation of matter. In a closed system, matter remains constant. Which means that in any type of reaction or chemical experiment, the mass must remain the same. And for us, we will see that the number of atoms will remain the same. Number of atoms total needs to remain the same. So if we look at this, I have an example here that's already what we call balanced. We have 2 Mg plus O2 yields 2 MgO. And if you remember from last week, we can identify this type of reaction as a synthesis reaction. We have two things coming together to form one thing. And we have these numbers in front here. And there's nothing in front of the O2. We're going to call these numbers in front coefficients. And we use coefficients to balance a chemical equation. They tell us how many of each atom or compound we need or molecule we need in a chemical reaction to keep it balanced, to keep a conservation of mass. And so we like to show this using particle diagrams, and I like to use different colors. So it says I have 2 Mg. It was already balanced for us, so I'm going to have 2 Mg. I'll use blue for O2. It's O2. It's a molecule. It's connected. So I'm going to just say O2. And then I have 2 MgO. MgO is going to be a red circle and a blue circle. Red, blue, red, blue. Now let's count and make sure that we have a conservation of mass, or we have the same number of particles on each side. I have 2 red particles, or 2 magnesiums on the left side, and I have 2 red particles, or 2 magnesiums on the right side. I have 2 blue particles connected on the left side, and I have 2 blue particles connected elsewhere on the right side. This is conserved, and this is what we call balanced. This is an already balanced chemical equation. Something that I didn't show here is that there's only one O2. We do not have to write the number 1 as a coefficient if it is involved or required for a balanced chemical equation. It's kind of like in math, where we don't write 1x, we just write x. Or we don't say x to the first, we just say x. So it's a coefficient of 1, and 1 you don't have to write into a chemical reaction or a chemical equation. We are going to use these particle diagrams as a helpful tool to balance chemical reactions. So I'm going to show us now in question 1, or in example 1, how we could work to get a balanced chemical equation. So let's look at 1. I have these blanks here. These blanks here are going to be for coefficients that we eventually have to fill in. This says H2 plus O2 yields H2O. Let's start by drawing particle diagrams. I'm going to use purple for H2. So I have H2. And then I'm going to use green for O2. O2. And then on the right side, I have H2O. So that's going to be 2 purples and 1 green. So 1 green, 2 purples. Let me count and see if I have a balanced chemical equation. So I have 2 purples on the left side, and don't forget, this left side we call the reactants, and this right side we call the products. So on the left side, I have 2 purples. On the right side, I have 2 purples. That's good so far. On the left side, I have 2 greens, which is my O2s. On the right side, I only have 1 green. We need to make sure for a balanced chemical equation that before and after, or reactants and products, I have to have the same number of atoms on each side. That's conservation of mass. So what am I missing, or what do I need to add, or what's missing between the left and right side? If you look at this, I have 2 greens here and only 1 green here. That green corresponds to oxygen. I need to add another oxygen on this side. And some of you might think, okay, let me just do this then. Let me add an oxygen. Well, is this one single oxygen a part of the chemical equation or chemical reaction? It's not. The only way that I could add oxygen on this product side or this right side is by adding a water molecule or H2O. So not only do I have to add an O, I have to add another 2 H's. I have to add another water molecule if I need more oxygen. This is how we balance. You can't just randomly put atoms wherever you feel like it. You have to put the atoms that are involved in the chemical reaction. So now let me check. Okay, I have 2 greens, which is my 2 oxygens. That's good. 2 oxygens, 2 greens. That's good. I have now 1, 2, 3, 4 purples, which are my hydrogens. Okay, but I only have 2 hydrogens here. Now what do I have to do? I need 2 more hydrogens on this left side. All I have to do is add another H2. And now I have the same number of atoms on both sides. I have 4 purples, 2 greens, 2 greens. Now we're going to put in what we called, or what I mentioned, is the coefficients. I have 2 H2s that were required to have the same number of atoms on both sides, which is what we call balance. So I put a big 2 here. I have an O2. You don't have to put in the 1, but I'm going to do it for effect. I only need 1 O2. And if I put these 2 together, I will get 2 H2Os. And now this chemical equation is balanced. We call it a balanced chemical equation because the number of atoms are balanced or in the same amount on both sides. Let's do another example. We have H2 and Cl2 to yield HCl. So let me keep H as purple. So I have H2, and I'll make Cl blue. Cl2. It says Cl2, blue. And on the right side, I have HCl, blue and a purple. And you already can see right here that I have 2 H's, 2 Cl's, and I only have 1 H and 1 Cl on this side. I need 1 more H and 1 more Cl on this side in order for this to be balanced. So in order for me to get 2 H's on this side, or even 2 Cl's, I need another HCl. So I could draw that in. And now that's balanced. I have 2 H's on this side, 2 H's, 2 Cl's, 2 Cl's. And now I could put the coefficients in. I only need 1 H2 to give me those 2 H's. I only need 1 Cl2 to give me those 2 Cl's. And I make 2 HCl's. This is balanced. Let me jump to a little bit more of a complicated problem. What if we throw something like question number 6 over here? And I'm going to eventually do the answer key and explanation for all these questions, but just for the purpose of this video, I'm just going to do a complicated one like number 6. Number 6, we have NH42SO4 plus AlCl3 yields Al2 parentheses SO4 plus NH4Cl. Seems like a lot. There are a lot of atoms there. But if you have heard or seen or remember, NH4 is a polyatomic ion. That's ammonium. And notice how it kind of stays together, NH4 and NH4. Same thing with SO4. SO4 is actually SO4 2-. That's sulfate. That's a polyatomic ion that's going to stay together. So I'm actually going to draw NH4 in a particle diagram as a whole thing of itself. I'm going to say NH4 is going to be a big blue circle. And I'm going to say SO4 is going to be a big red circle. And then we have aluminum, Al, and chlorine, Cl3. If I were to name these, this is ammonium sulfate and aluminum chloride. And then I get aluminum sulfate and ammonium chloride. I'm going to use different colors for aluminum. I'm going to say aluminum is going to be green. And chlorine, I'm going to make that purple. And for AlCl3, there are 3 purples. So I've got AlCl3. And now I have NH4, 2, SO4. That little 2 means I have 2 NH4s, and there's only 1 SO4. So I'm going to draw this compound like this. I'm going to have 1 SO4, and then I'm going to have 2 NH4s. I just made them big. So I have 2 NH4s, 1 SO4. There you go. And then I have 1 Al and 3 Cls, AlCl3. And then on the right side, I have one compound that has 2 Als and 3 SO4s. Remember, SO4 is red and Al is green. So I'm going to draw 2 Als, and then I'm going to draw 3 SO4s around them. Doesn't matter how you draw them, as long as you draw them. Doesn't matter how you draw them. You could have them connected in a circle, all connected together, but this has my 2 Als, and it has 3 SO4s. And then I have one NH4 and 1 Cl. So I have 1 NH4, and then we use purple for Cl. You could choose which one you want to start balancing. Doesn't matter. But let's look at an atom or an amount that's not the same on both sides. So I'm going to look over here, and I see that I have 3 sulfates on this side, but only 1 sulfate on this side. I'm going to need 3 sulfates on this side. This is how you could balance. You just choose an atom that there's not the same amount and just start adding. So I have 3 sulfates on this side and only 1 on this side. I need 2 more sulfates on this side. The only way that I could do that is if I add 2 more of these ammonium sulfate compounds. So let me do that. Here are my 2 sulfates that I'm adding, and then here are the ammoniums that are attached to them. Now my sulfates are good. Sorry, my camera's getting a little messed up. Now my sulfates are good. I got my sulfates. 3 of them. Now I see that I have 1, 2, 3, 4, 5, 6 of my ammoniums. And I only have 1 ammonium here. Well, I need to add 5 more ammoniums. And if I'm adding ammoniums, I need to add those chlorines. So far, so good. With my ammoniums and my sulfate, I have my 3 sulfates, my 6 ammoniums. Let's see. I have 2 aluminums here. Aluminums are green for me. And I only have 1 aluminum here, 1 green here. Well, I need to add another one of these then. And it just so happens that that's going to help balance the chlorines. This is a tough one. And so now I have 3 sulfates, 6 ammoniums, or 6 of the blues, 6 blues. I have 2 greens, or 2 aluminums. And then I have 1, 2, 3, 4, 5, 6 purples, or 6 chlorines. 1, 2, 3, 4, 5, 6 purples, or 6 chlorines. This is balanced then. Now let me put in my coefficients. I needed 3 of these ammonium sulfates, so a big 3. I needed 2 of the AlCl3s. I made 1 Al2SO43, and I made 6 NH4Cls. So I wanted to end with a tough problem. There will be other videos that are posted that do other examples of other problems from this handout. Hopefully this was a bit helpful on how to begin to balance chemical equations. The best thing you could do is use the particle diagram method.